Okay, so as mentioned, we're starting section 7 of chapter 4, which is law of sines and cosines. And we're sticking to law of sines today, which may actually take us several days to get through this note packet. I'm not 100% sure on the timing because I haven't taught it at the pre-calc level before. But I've taught it dozens of times at the Algebra 2 level, so I have 100% confidence that I'm doing everything right. So, law of sines. Earlier in this chapter, even, we've discussed how to deal with right triangles. And when we dealt with right triangles, we had 3 pre-established from geometry tools that we could use to solve right triangles. We had the Pythagorean theorem, which we're all very comfortable with, a squared plus b squared equals c squared, where c is the hypotenuse. Yes? It relates to 3 side lengths of our triangle. We had the angle sum theorem, which in any triangle, the 3 angles add up to 180 degrees. That will still be true, even when we're dealing with non-right triangles. And then last and not least, we had everybody's favorite, basic right triangle trigonometry, SOHCAHTOA. Okay, those 3 things applied to right triangles, and as such, we can still use them, although we're going to have to make some slight alterations to a couple of them because, for instance, Pythagorean theorem only applies to right triangles. Yeah? SOHCAHTOA only applies to right triangles. The angle sum theorem works still, no problem there. Okay, but the other 2 are only for right triangles, so they're really not going to be a whole lot of help to us anymore. So here in this section now we're going to be talking about the law of sines and eventually the law of cosines. But the law of sines is for triangles that do not have right angles. Now it does work for right triangles as well, but these 2 rules are general rules that apply to all triangles. Obtuse, acute, right, scalene, isosceles, equilateral, doesn't matter. These rules work for every triangle. Okay? So the law of sines states that the sine of angle A is to the side length opposite, as the sine of angle B is to the side length opposite, as the sine of angle C is to the side length opposite. In other words, if we know 3 of these pieces of information, we can set up and solve a proportion. Okay? Now, interestingly, and I am a little bit surprised that we're not doing the derivation of this rule, but this is based on SOHCAHTOA. It's actually based on an area theorem for all triangles. Okay, but essentially note that for angle A, the side opposite is little a. For angle B, the side opposite is little b. And for angle C, the side opposite is little c. Notice how the angle name and the side length are with the same letter. Okay? So we're saying the sine of angle A over A equals the sine of B over B equals the sine of C over C. And we'll never use all 3 at once. We'll use 2 of them to set up and solve a proportion. Okay? In order to do this, we must have a side length and angle measure combination. We cannot do it unless we have one full set. So like angle A and side A, if we know both of those, we can use the law of sines. But if we don't know both of them, we can't. So we've got to have one full set of matching angle and side length. When we use the law of sines, it is possible that there could be 0 solutions, 1 solution, or 2 solutions for that particular triangle. The 2 solutions is known as the ambiguous case, and we will talk about that at the end of this note packet. Another thing to note, solving a triangle means we find all 6 components of the triangle. All 3 side lengths, all 3 angle measures. A triangle is not considered solved until you know everything about it. All 3 angles and all 3 sides. Okay? And then when we use the law of sines, We'll work with both degree and radian measures. We need to be comfortable with both, and we need to be prepared as necessary to shift our calculator back and forth between degrees and radians. Okay, we need to be prepared for that. Okay, so example 1 asks us to solve this triangle, and it is an example that only has one solution. What I mean by that is there's only one triangle that has the measurements given. Okay? Now to solve this, we need to find everything that we don't know. So in the picture, we know 3 of the 6 things right now. We know the measure of angle A, we know the measure of angle B, and we know little b, the side length opposite angle B. Yes? So that's what we know. Okay? And as with any problem-solving problem, what you got to do is you got to ask yourself, what do I know? What do I need to know? How do I find it? Yes? And that's problem-solving 101. So we need to know 3 things. So what I usually have my students do in A2 is I have them make themselves answer boxes for the things they need to find so that they don't forget one of the answers. Does that make sense? So we need to find angle C, we need to find little c, and we need to find little a. Now, of those 3 things, right now, we have enough information to find 2 of them. The easiest one to find is the measure of angle C. How do we find the measure of angle C? Add the other 2 together and subtract from 180. Okay? So the easy part here is that the measure of angle C is 180 minus the measure of the other 2 angles. So that's 180 minus 35 minus 103. And that is a 3, not an 8. Okay? So that gives us the measure of angle C is what? Say what? 42? 42 degrees. And it's in degrees, so our calculator needs to be set to degrees. Okay? Because all of our angle measures are in degrees, so our calculator needs to be in degrees. So hit the mode button and make sure your calculator is set to degrees, not radians. Sadly, you're going to have to be comfortable switching back and forth. Okay? Actually, I'm guessing all of them on their notes and in our homework will probably be in degrees, but let's be prepared for that. Okay? Now, once we know that angle C is 42 degrees, now we need to use the law of sines. Okay? Notice that we know the measure of angle B, and we know the length that's marked little b. We know that pair, right? So we're going to use that pair. We're going to use the sine of B over little b equals. Which one do you want to find first, A or C? It makes absolutely no difference. You tell me. A? Okay. Then we want to set up sine of B over little b equals sine of A over little a. Because of the 4 variables in that proportion, we know 3 of them, which means we can solve for the 4th. Okay? So that would be sine of 103 degrees over 20 equals the sine of 35 degrees over little a. I just forgot the degree symbol. Yeah. You're right, I should make sure I have that because otherwise it's 103 radians. It's got to have the degree mark, right? Precision. Okay, now how do you solve any proportion? Cross multiply. So, we cross multiply. We do 20 times the sine of 35 equals A over the sine of 103, or times the sine of 103. Remember that cross multiplying results in an equation. It doesn't result in a fraction. Okay, don't try to jump that step. Now, if we want A, what do we need to do to get A by itself? Yep, we need to divide by the sine of 103 degrees. So A is equal to 20 times the sine of 35 degrees divided by the sine of 103 degrees. Now, when you're typing that in the calculator, be very, very careful. Make sure you close any parentheses that your calculator opens. You got one of these, it's much easier because you can use the fraction button. Okay, but those graphing calculators, be very careful when you type that in, and I do want you to practice typing it in to make sure that you can get it right. So, 20 times the sine of 35 degrees divided by the sine of 103 degrees, 11.77. Now it says round all lengths to the nearest tenth. So if we have 11.77, what does that get rounded to? 11.8. And our units, we don't have any, so we just write units. So little a is 11.8 units. Okay? Now, we're going to do essentially exactly the same thing to find little c. The only difference being that instead of doing sine b over b equals sine a over a, we're going to replace the a's with the c's. Okay? So we will do the sine of b is to little b as the sine of angle c is to little c. And please, I know that little c and big C look the same. Please make sure you're putting the angle with the sine and the side length by itself. Okay? It's the biggest mistake people make is they try to plug angle c in here instead of with the sine. So that would be the sine of 103 over 20 equals the sine of our newly discovered 42 over c. And the work will essentially be identical to what we did for little a. So cross multiply 20 sine of 42 degrees equals c sine of 103 degrees. And then divide by the sine of 103. So c is 20 times the sine of 42 degrees divided by the sine of 103 degrees. And we feed that into our calculator. Okay, cross multiply and then divide by the sine of 103. So, 20 times the sine of 42 degrees divided by the sine of 103 degrees. 13.73. So how would that get rounded? Yep, 13.7 units. And if you create your own answer boxes, you can just circle them, and we are good to go on that example. So the second example, this example is going to have 0 solutions, and it will become rapidly obvious why it doesn't have a solution. Okay? Notice what we know this time. We know a lot more than we knew last time. Right? We know all 3 side lengths, so the only things we need to find are the measure of angle P and the measure of angle W. Okay? We know the other 4 things. They're all there already. We know that 5 is going to be little s because it's opposite angle S. We know that 6 is going to be little w because it's across from angle W. And we know that 9 will be P because it's across from angle P. Okay? So we got all that information. We're supposed to solve this triangle. Now I will tell you that a good rule of thumb is always to find the largest unknown angle first. So which of those two angles is bigger, angle P or angle W, and how do we know? Think geometry. Which one's bigger? P. Why? Yeah, little p is bigger than little w, right? So this side's longer, which means that angle's bigger. Okay? Hinge theorem, I believe it was called. No, I'm sorry, that's not hinge theorem. That's the one that I named. I call it the SLAM theorem, the side length angle measure theorem. It doesn't have an official name, so I had to give it one. Okay? The biggest angle is always across from the longest side. The smallest angle is always across from the shortest side. Okay? So, I would find angle P. So to do that, we would say sine of angle P over little p equals, and then we have to use the s's because that's the pair that we know. So the sine of angle S over little s. Okay? Plug in what we know. We do not know angle P. Little p is 9 units. Sine of S is 78 degrees. And little s, amusingly, is the number it looks exactly like, 5 units. Cross multiply. So we're basically doing the same steps we did on the last one. We cross multiply. And we get 9 times the sine of 78 degrees equals 5 times the sine of p degrees. How do we solve for our variable here? What do we do? Divide by 5. Good. That's step 1. That gives us the sine of p is 9 times the sine of 78 degrees divided by 5. Now how do we get p by itself? How do we get rid of sine? Sine to the negative first, arc sine, inverse sine, whichever way you're comfortable with me saying it. We need to take the arc sine. So P is supposed to be the inverse sine, so you hit second sine, of 9 times the sine of 78 degrees divided by 5. Put that into your calculator, see what happens. Put that into your calculator and see what happens. So when you type that into your calculator, it should not work. Because 9 times the sine of 78 degrees divided by 5 is approximately 1.76. And the sine function only works between 1 and negative 1. So 1.76 is not in the domain, which means when you tell your calculator to look up this value, it's going to return, I can't. That is a domain error. And as soon as you see domain error, that's how you know that this has no solution. So you would simply go back over here and you would say, no solution. And that problem is considered solved because no such triangle exists. Okay, third example here has one solution as well. And again, that would only be evident because we'd go through it, and that's how we get there. Okay? So we look at what we know. This time they, again, have done us a bit of a favor. They've given us more information than they have to. To solve a triangle, you have to know 3 sets of information, including at least one side length. So they've given you all 3 side lengths and angle B. Okay? So we need to find the measure of angle A and the measure of angle C. That is what we need to find. Okay? Again, I always suggest that you create little answer boxes for yourself so that you do not forget to state an answer. Because in order to finish the problem, you have to tell me everything that wasn't given in the problem. Okay? So, looking at that picture, little b is 11.2, and that is the longest side of the triangle, which means that those other two angles have to be less than 102. Okay? Little a is 10, and little c is 3.4. Again, we name those based on which angle they are opposite. Which is bigger, angle A or angle C? A, very good. So we're going to find angle A. So we're going to say sine of A over A equals, and then we have to use the B's because that's the pair where we know both pieces of information. So we'll do sine of B over B. Plug in what we know. So we have the sine of angle A, we don't know what that is, over 10 equals the sine of angle B, which is 103 degrees, over little b, which is 11.2. So plug in what we know. Cross multiply. So we'll do 11.2 times the sine of A and 10 times the sine of 103. So we have 11.2 times the sine of angle A equals 10 times the sine of 103. To solve that, we need to divide by 11.2. Which gives us the sine of A is 10 times the sine of 103 divided by 11.2, 103 degrees. And then arc sine. Take the inverse sine of that nonsense. So A is going to be the inverse sine of 10 times the sine of 103 degrees divided by 11.2. Now I'm looking at that and I'm seeing 10 over 11.2 is less than 1. So this one probably is fine and will exist. Right? So we have the inverse sine of 10 times the sine of 103 divided by 11.2. We are told to round any angle measure to the nearest degree. So A is approximately 60.4 degrees, which means we round it down to 60 degrees. Because that's what the directions tell us to do. 60.4 would round down to 60 degrees. Now, in this case, the only other thing we need to find is the other angle. Do we need to do the law of sines again to do that? Absolutely not. If we know two of the angles, the third one is easy to find. The third angle, in this case angle C, would be 180 minus B and A. There's no reason to do, you could do the law of sines again. It would work, but it's unnecessary. It's harder than you need to make it. Okay? So that would be 180 minus 103 minus our newly minted 60, 17 degrees. And we're done. I think we're going to save the ambiguous case for tomorrow. Everybody okay with us stopping there for the day?